Hello, my name is Nitali. Today I will present about development of a privacy-focused Khmer chatbot based on Retrieval-Augmented Generation. Here is the content of the presentation. We have introduction, methodology, result, and conclusion. Moving on to the first part, which is introduction. We know that large language models like ChatGPT, Gemini, and DeepSeek have transformed how people access information. However, these general-purpose models do not work well for low-resource languages such as Khmer. The Khmer language lacks digitized corporas, annotated dataset, and domain-specific pre-trained model. As a result, many institutions still rely on human assistance for information retrieval, leading to delays, higher cost, and no support after office hour. Here's the example. We ask ChatGPT, "Tao Heng Pitu Chinona," which means who is Heng Pitu? It says Heng Pitu is a footballer in the Cambodian football team, which is not correct. Actually, Heng Pitu is one of the famous singer in Cambodia. And the second question is, where is Cambodia? It says Cambodia is on the planet Earth. We also try asking DeepSeek, who is Heng Pitu? It says Heng Pitu is a former president of the opposition political party in Cambodia. And when we ask Gemini, who is Heng Pitu? It says, I don't have enough information to tell you who Heng Pitu is. So existing chatbot models cannot accurately handle Khmer, especially for localized or domain-specific questions. Most AI services rely on cloud-based APIs, which pose serious privacy and security risk. Institutions dealing with sensitive data, example bank, government, cannot afford to leak internal documents. Thus, there is a growing need for a secure Khmer-capable chatbot that function privately within organizational boundary. So in this study, we propose a chatbot built on the Retrieval-Augmented Generation or AG framework. The system operates fully offline within a secure infrastructure. Internal documents are embedded and stored using a self-hosted Far-East database. The chatbot uses LLM to generate answers only from retrieved documents, preventing external information leakage, and no sensitive data is sent outside the system, ensuring complete privacy. This project aims to develop a privacy-focused Khmer chatbot designed for internal use within organization. Besides that, we also access and compare 5 pre-trained language models for Khmer question answering. We also test embedding model for document retrieval performance. Also, we deploy a private Khmer language chatbot using OIG architecture. Besides that, it also contributes to Cambodia's digital transformation by supporting SDG 9, by supporting resilient infrastructure and innovation. Also support SDG 16 by promoting inclusive institutions and access to information. Moving on to the methodology part, our dataset is collected from 2 different sources, OSCAR, open source large scroll aggregated corpus, and Wikipedia. The dataset from OSCAR was 146 text files, is around 10 million words, and dataset from Wikipedia is 2,482 text file, is around 7.8 million words. It is also important to mention that this full stop or period in English is equal to this sign in Khmer. And here is the example of the Khmer corpus. The text in the dataset are run through word segmentation to add space between words using conditional random fields, CRF. CRF is a method used to predict a sequence of labels based on the surrounding context in the input data. The structure of Khmer language is different from language like English, as there are no spaces between words, making it difficult for the model to identify word boundaries, which is crucial for generating meaningful text. Due to the time constraints in running the LLM model, we are selecting only 10 datasets from the OSCAR corpus to study, rather than using the entire dataset. In the implementation part, we first compare 5 different pre-trained models from Hugging Face. First one is CLM. Second one is AI Singapore. And then 3 models from Kim Ding 123, Gamma, Mistral, and Qwen 2. After that, we chose the optimal model among the 5. And then we proceed to integrate it into the OIG framework. In the process, we also compare the embedding model, sentence transformer, all mini LM L6V2, and infloat multilingual E5 large. And after that, a chatbot is created using radio. Let's look at this diagram. Dataset is split into smaller, meaningful, or chunk sections to improve retrieval efficiency. And then each chunk is transformed into a dense vector representation using a pre-trained embedding model that captures the semantic meaning of a text. These vectors are stored in the face database, enabling rapid similarity search. When a user submits a query, the input is similarly converted into a vector using the same embedding model. A Gaussian similarity search is performed against the database to retrieve the most relevant content chunks. The retrieved information is then incorporated into a structure prompt, which is passed to LLM for response generation. Moving on to the result and conclusion, we first use these 3 evaluation metrics to compare the 5 pre-trained model. First one is perplexity. Perplexity measures how well a language model predicts text. Lower perplexity means better predictions. Second one is CHRF++, character and gram F score. It evaluates translation equality by comparing character sequences instead of words, making it effective for morphologically rich language. Latency is a time delay between input and response. Lower latency means faster chatbot replies, improving user experience. Let's look at this table. First, we give the prompt to evaluate these 5 pre-trained model. We give the prompt "Susday Nikujikat Fote." It means hello, this is a test. And we see that the CLLM 7B chat and the fine-tuned Mistral model seems to perform better as compared to other models because it gives the lower perplexity score and latency and also higher CHRF++ score. Now let's look at this. Then we give another prompt. So say प्रयोग पीछे पे Khmer ampi paritan, which means write 2 sentences in Khmer about environment. And then it generates responses as below. We can see that among all this, only the serial V3 is when we chat that produces answer that is makes sense or more meaningful as compared to others. So the response from CLM 7B chat was noticeably more accurate, grammatically correct, and semantically coherent than those of the other models. Based on both quantitative metrics and qualitative evaluation, we select CLM as the most suitable model for the Khmer chatbot framework. Moving on to embedding models comparison. To compare these 2 embedding models, we asked a question: who is Hein Pitu? And this embedding model reply generate the response as Hein Pitu is a famous singer. Hein Pitu cedera cemberut muncul beban stop jua vai. Whereas all mini LM L6V2 it reply just half, not even half, just Hein Pitu blah blah something. So therefore we select multilingual E5 large as the embedding model for our system. Moving on to chatbot comparison. We have compared 3 chatbots. The first one is ChatGPT. The second one is original CLLM. And the last one is our framework, which is CLLM, integrated with the OAG framework. We ask a few questions. First question is Hein Pitu Chinone, who is Hein Pitu? And ChatGPT reply, he is the footballer in Cambodia. While CLM reply, sorry, I cannot provide more information. If you have any other question, please see more information so I can help you. Let's look at our framework. It says Hein Pitu is a famous singer among young people, which is absolutely correct. The second question is, who is the Minister of the Interior of Italy? ChatGPT reply, François Hollande. Original CLM reply, Aymeric Chopret. While our framework reply, Italy's Interior Minister is Matteo Salvini, which is correct. Last question. When did President Barack Obama present the Freedom Medal to Bob Dylan? ChatGPT reply, 2005. Original CLM reply, 1990. While our framework reply, 2012, which is correct. So our OAG enhanced CLM chatbot consistently produces answers that are not only more accurate and relevant, but also contextually relevant and grammatically correct, aligned with the information stored in the reference documents compared to the other two systems. Based on these observations, we conclude that the OAG enhanced CLM P3 chat configuration is the most suitable model for building a privacy-focused Khmer chatbot, as it outperforms the alternatives in terms of accuracy, relevance, fluency, and fidelity to reference content. Moving on to the conclusion and future work, this project successfully developed a privacy-focused Khmer chatbot using CLM 7B chat integrated with OAG framework. By combining it with the inflow multilingual E5 large embedding model, the chatbot provides accurate context-aware responses even in a low-resource language environments like Khmer. The system enhances information access while ensuring data privacy, making it ideal for internal use within organizations. Besides contributing to Cambodia's digital transformation and supports SDG 9 and 16, it also helps reduce operational cost, improves efficiency, and eliminates the need for external cloud services. As a next step, we plan to enhance the chatbot's capability by generating training data from text extracted from image-based documents, examples Scan PDF. Furthermore, due to the absence of standardized Khmer evaluation metrics, formal benchmarking was not conducted. But future work will focus on developing or adopting such metrics to enhance performance assessment. Here's some of the references we have. So thank you for your listening. If you have any question in English, you can ask me. Here's my contact information. And if you have any question in Korean, you can ask Ji-Yun Moon. That is her contact information. And here's our corresponding author, Professor Cham Gil-hong. That is his contact information. Once again, thank you.